Try again. Let's try this again. Okay. Now we have a pen. Should work. Y equals. Let's go with a cosecant. Whoops. Cosecant. Whoa. Theta. Holy. Theta. Graph. That's a nice S I've got there, though, isn't it? Let's erase that and let's make it a little bit prettier. Cosecant theta. Look at how pretty that is. See, I wonder if I should use the pen even next time. Yeah, like it comes with pen, so we'll try it later. Okay, so y equals cosecant theta. So now we got to think of the unit circle as well. Okay, so we're talking 1 over. Now, like you said, Todd, we know it's a reciprocal graph of 1 over the sine of theta. So we'll do it one way for the cosecant graph, and then we'll look at it for secant graph because they're very similar, just like sine and cos are very similar, right? Okay, so at 0 radians, what is sine theta? It's 0. So on the unit circle, at 0 radians, sine is 0. So when we look at the cosecant then, at 1 over sine theta, at 1 over sine theta, can we have 1 divided by 0? No. So what do we call that when you can? It becomes an asymptote. So I'll change the color and I'll go to green. So we know that we have an asymptote running at 0. So let's just really quickly think about all the different places where sine is 0 then. Where else is sine 0? At pi. So obviously I have an asymptote at pi. Where else then? 2 pi. Okay, so 2 pi. And can I just keep going like this? Because we know it's sinusoidal. So, or periodic, I should say. Every pi then means we, and I'll even go over here, at negative pi, right? Because that's basically what that is. And we've got asymptotes. So again, if I jump back, and I'll go with blue maybe for the graph part, just a little bit easier to see instead of black on black. All right. Let's think about this now again. So tan, or not tan, cosecant, sine at pi over 2. What would sine be? At pi over 2. Yeah, 1. So 1 divided by 1 is 1. So at pi over 2, which is right there, I can go up to 1 and put my point, right? Oops. Get out of there. So I've got a point at 1. Okay? Then if I go around the unit circle all the way to 3 pi over 2, what is sine equal at 3 pi over 2? Negative 1. So 1 divided by negative 1 is negative 1. So cosecant at 3 pi over 2, which is right there, is negative 1. Okay. So I'll erase my pi over 2 points there. Okay. So now let's just kind of we'll use pi over 3's because they're on there. So at pi over 3, what does sine equal at pi over 3? What is it? No. At pi over 3. Think about where that is. It's the top, yeah. So where is it? Not 1/2. What's the other one? Right? So now when I put that in for sine theta, when we're doing the reciprocal, 1 divided by root 3 over 2, obviously we reciprocal the root 3 over 2 becomes 2 over root 3. Real quickly, somebody tell me what 2 divided by root 3 is then. On your calculator or whatever device you got. What's 2 divided by root 3? Because we need to know this. I'm going to make these points a bit bigger here too. What do we got? 1.15. So at pi over 3, it's like up here, right? And the same as 2 pi over 3 as well, because we know that the sign is positive there. And, okay, let's jump over to 4 pi over 3. At 4 pi over 3, it's just the negative versions, right? Agreed? Okay, so then it would be a negative 1.15 and a negative 1.15. So if we followed the asymptotes, because we can see from our points that our graph is starting to head out, right? And in this bottom one, same thing, right? We've got it like this. And because it's periodic, or we know it's a periodic function, we can make some pretty nice assumptions, or go around the unit circle, or keep going around the unit circle until we have this whole deal, like so. And obviously it would keep going. So there's your cosecant graph. Now the secant graph is almost exactly the same, except just like sine is to cos, or cos is to sine, cosecant to secant. What do we do with our graph? Shift it. Yeah, it's going to be a horizontal or a phase shift to our secant graph.